Hello everyone, hope you're doing well. So in the previous video, I explained to you about the columns and struts. I also explained about the difference between what exactly is a column and what is a strut. And then we also got to see about the types of columns based on the slenderness ratio. And then I even explained to you about the different end conditions of the column and the way in which we can derive the effective length of the column. And then finally, I explained about the Euler's formula and Rankin's formula. Now, in this video, I am going to explain to you about the steps of solving the strength of column problems using the Euler's formula, and also we will be solving some questions as well. Alright, so now moving into the steps of solving the problem using the Euler's formula. In the first step, you need to write down all the important information from the question. Okay, so this is because when it comes to solving the problem, it's like you will be under a lot of stress. Okay, and then when you just try to find out one particular important information, you will have to go through the entire question to point that out. Okay, so the best way is to write down all the important information from the question in our solution. So this is actually going to help us save our time, and also it's going to help us in writing the exam well. Okay, because all the information will be present already. Then once you are done with the step 1, in step 2 you are going to calculate the minimum moment of inertia. Then in step 3, based on what is the end condition given in the question, we will calculate the effective length of column. And then finally, when we have all the required information, we will substitute it into the formula, and then that's how we are going to go ahead. All right. So now let's go into the question. So I have already written the question over here. Now let's start solving it. So as I told you in the first step, we are going to write down whatever is given in the question. So let's do that. The first thing which I can see over here, okay, let's read through the question. A rectangular column of size 100 mm by 70 mm is of length 6 meters with both ends hinged. Calculate the strength of column by Euler's formula. Take Young's modulus E as 2 into 10 power 5 Newton per mm square. Okay, so this is the information which is given in the question. Now let's write it down. So the first thing is with B. Okay, it is a rectangular column, so B and D both are going to be different. So B is 100 mm, D is 70 mm. Then the length of the column is given. So length of column L is given as how much? It is given as 6 meters. Let's convert this into millimeters also, because here we have it in millimeters. So you can either write it as 6000 millimeters. You can also write it as 6 into 10 power 3 millimeters. Okay, this is one way. Now, what is the condition given in the question? The condition of the end columns, okay, is given as both ends hinged. Okay, this is the condition which is given in the question. Now, let's move on. So, even the value of Young's modulus is given. So, E equals to 2 into 10 power 5 Newton per mm square. Okay, this is the information which is given. Now, once you are done writing whatever information is given in the question, let's just write down the equation over here. Okay, whatever the formula is, and as you can see, they are mentioning that we have to calculate the strength of the column by Euler's formula. Even if this line is not given, just by understanding that E is given in the question, we should understand that this is the Euler's formula. Alright, so once you are done writing down whatever is given in the question, write this. general equation. So what is the general equation? The general equation for Euler's, okay, to find out the strength of the column using Euler's is PE equals to pi square EI minimum divided by L effective whole square. Okay, this is the formula that we have to use. Let's highlight this in a box. Okay, now going into the next step. Okay, so what was the next step? We are supposed to calculate the minimum moment of inertia. So okay, so let's do that. Calculating minimum moment of inertia I minimum. Okay, this is let's do that. Okay, so as I told you in the first video, there are different formulas of moment of inertia depending on what type of section of the column is. And as you can read in the question, this is a rectangular column. Okay, it is not a hollow rectangle, it is just a rectangle. So for that, in order to find out I minimum, we have to find out Ixx and Iyy. Okay, if you remember in the first video. So Ixx, okay, moment of inertia formula for a rectangle is BD cube by 12. And for Iyy, it is DB cube by 12. Okay, so let's write it down. So B, as you know, is 100 and D is 70, but we have cube over here. So let's do that. So 100 into 70 cube divided by 12, and the answer will be 2.858 into 10 power 6, and the units are mm power 4. Now, when it comes to writing down how many numbers, how many decimals after the point, I would suggest that in order to get a precise answer, you should see this is just my opinion. So you should write three decimals after the point. Okay, and when it comes to the units, B is mm, D is also mm, but over D we have cube. So cube into will be power 4. Now coming to here, 70 into 100 cube divided by 12, and the answer is 5.833 into 10 power 6 power 4. Okay, so we have got the two values, okay, of the moment of inertia for a rectangular section. So we have Ixx and Iyy. Now if we compare them both, which value of moment of inertia is less? This value is less. Okay, Ixx value is less when we are comparing it with Iyy. So therefore, I minimum equals to Ixx equals to 2.858 into 10 power 6 power 4. Okay, so we have got the value of I minimum. Now, an important thing before we proceed into the next step. Okay, the important thing is that if you are not able to recall what step we have to do, just follow the formula. Okay, so E, the value of E is already given in the question, so I'm not doing anything over there, but we have to find out I minimum. So this is what I'm solving right now. And the next thing which I'm going to do is I'm going to find out the value of L effective. Okay, so we are done with the calculations of minimum moment of inertia. Now let's calculate the effective length of the column L effective. Let's do that. Calculating effective length of column L effective. Okay, so if you remember in the question, they have mentioned that both ends are hinged. Okay, so since both ends are hinged, Since both ends are hinged, the L effective formula will be L. Okay, whatever L is, that will be the effective length. So L effective equals to 6000 millimeter. Okay, this is what L is given as. Okay, so if in case this was not both ends hinged, it was something else, so we would have substituted the value of L over there and derived the answer for effective length. Okay, so now we have L effective, we have I minimum, and in the question they have already mentioned what E is. Now let's substitute it back into the formula. Okay, let's do that. So let's do that. So now, what is the formula? Let's write it down once again. PE equals to pi square EI minimum by L effective whole square. Okay, so pi square into what is the value of E? It is 2 into 10 power 5. Next, I minimum. What is I minimum? Here we have the value of I minimum. Let's substitute it. 2.858 into 10 power 6 divided by L effective. What is L effective? It is 6000, but we have L effective whole square. Please don't forget that. Okay, it is going to cost you your marks, your precious marks. So don't forget that. Alright, so now after solving all these things, the answer will come as 156.268 into 10 power 3 newtons. Okay, we can convert this newtons into kilonewtons. Let's do that. Okay, and how can we do that? We can simply do that by dividing it with 10 power 3. Okay, and why are we dividing it with 10 power 3? Because 1 kilonewton is equals to 10 power 3 newtons. Okay, so we are dividing this because we are converting a smaller unit into a bigger unit. So in that case, you will have to divide it. If in case you are converting from a bigger unit to a smaller unit, let's say you want to convert from kilonewtons to newtons, then what you will do, you will multiply that value, okay, that value of the bigger unit with its conversion number. Okay, like in case of kilonewton to newton, we will multiply it with 10 power 3. Just like how we are dividing it with 10 power 3. Okay, so now what will happen? This 10 power 3 and this 10 power 3 gets cancelled. So what will be the answer? The answer will be 156.268 kilonewtons. Okay, so this is what the question is asking us to find out. Strength of the column using Euler's formula. Therefore, strength of column using Euler's formula is PE equals to 156.268 kilonewtons. That's it, everyone. Okay, this was the problem in which we found out the strength of column using Euler's formula. And this is what, I mean, these are the steps that we have to follow in order to solve these type of questions. Okay, so what are the things that you have to remember? You just have to remember the formulas of moment of inertia, and you have to remember the formula for end conditions of the column, so that whatever end condition is given in the question, you can use that appropriate formula and get the value for effectiveness. Okay, so that's it, everyone. And most important thing is, don't forget the formula. Okay, Euler's formula and Rankins formula, they are very easy. All right, so that's it for this video, everyone. In the next video, I am going to show you how to solve the problem using Rankin's formula. Okay, like I am going to show you the steps, and then I am going to do some problems as well, expressing that steps that I have that I'll be showing in that video. Okay, everyone. So that's it. Please don't forget to subscribe this video and press the bell icon, because that's how you will get to know how and when I'm uploading any video. Okay, everyone. So thank you so much. And in the description, you will come across the timestamp, so that whenever you click on that timestamp, you will reach that particular uh, topic which I'm explaining in this video. Okay, and also you will come across some links related to, okay, the first link is related to the notes of this unit, and then the next link is related to the Telegram community that I have started. Okay, so that Telegram community is the exclusive community for these notes. Okay, for these notes, for these videos, I'll be explaining and I'll be uploading videos over there. Okay, everyone. So that's it for today. This is Ibrahim Sibgatullah, and have a nice day.